Hey guys, I hope you all are doing good. In this lecture, we will try to understand what are partial orders and total order relations, right? This is kind of like an introduction to a few of the topics that we need to cover. In the next one, we will try to understand what are Hasse diagrams and how to represent them, and then it would be followed by maximal elements, minimal elements, upper bounds, lower bounds, etc. Right? So if you don't understand what I'm trying to say or these definitions, that's totally fine. We will cover these definitions in the upcoming few lectures, right? So this is kind of like an introduction to it. This is going to be a pretty short lecture compared to the next few ones, right? And it's going to be pretty easy to understand, right? So let's start with understanding what is a partial order relation, right? A relation R on a set A is called a partial order if it is reflexive, antisymmetric, and transitive, right? So there's three special conditions, right? I hope you all already understand what does it mean by being reflexive, antisymmetric, and transitive, right? But I'll still give an explanation about what it means. So let's say I have some kind of a relation on R, right? Let's say A is 1, 2, 3, right? And let's say I have this R equals 1 comma 1 dot dot dot, right? I'm not trying to represent everything, but you understand that this is how we represent a relation. This tuple 1 comma 1 basically means that 1 is related to itself, right? So I hope you understand this basic definition. Now the point is, it should be reflexive. The reflexive point is that all the elements should be related to each themselves, right? So for example, if it's reflexive, then 1 should be related to 1, 2 should be related to 2, and 3 should be related to 3, right? So these are the three conditions for reflexive, right? That's one condition that we need to follow for partial orders, right? Second is that it should be antisymmetric, right? So I'll try to give a basic explanation about what is antisymmetric, right? Look, the basic point is you should remember the definition of what is antisymmetric, right? The point is that if A comma B is an element of R and D comma A is an element of R, then A is equal to B, right? Now the point is you always have to check for this one single condition when you're checking for whether a relation is antisymmetric or not, right? So you check if A, B is in a relation, right? So for example, let's say 1 is related to 2, 2 is related to 1. If the opposite is also there, right, and the elements are not same, right, if they're different elements, right? So for example, if I find 2 related to 1 and 1 related to 2, right, it is not going to be antisymmetric anymore. Similarly, if I find 3, 2, 2, 3, it's not going to be antisymmetric, but it is only true, it can only satisfy when the elements are equal to each other, right? So for example, if you look at it, 1 is related to 1 and 1 is related to 1, right? Switching, it doesn't really make a difference, but they are also equal to each other, right? So reflexive doesn't matter, but in the case different elements are related to each other on both the sides, it is going to be antisymmetric, right? Okay, now, okay, so last one is transitive, right? So transitive basically means if A is related to B and B is related to C, then A should be related to C as well, right? So whenever you're checking these conditions, just try to remember the definitions of what these conditions are and then check for those conditions only, right? It might be the case that you forget the actual definition and then you try to or you get confused when trying to compare, right? Okay, so you check for these conditions, reflexive, antisymmetric, and transitive. If it follows all these conditions, then you can say that the relation is a partial order, right? So if you get a question, do you think this is partial order or not? I think you should be able to solve it, right? Okay, second one is a set A with a partial order R is called a poset, written as A comma R, right? So whenever you have, let's say, some set A, right, and you have some kind of a relation R such that it is a poset, right? Such that it's a partial order, then we basically say that it's a poset and write it as AR, right? This is kind of like just a definition. I don't think there's much explanation behind it, but you should just remember that it's called a poset and you just represent it with A comma R, right? Okay. Now let's try to understand what is a total order relation. It is a special kind of partial order where every pair of elements is comparable, right? That is, so if you try to read this, it says for all the values a comma b in the set of A, either the tuple AB is in the relation or BA is in the relation, right? Look, the point is very simple, right? Uh, what this means is a relation is total order if all the elements are related to each other, right? So either A is related to B, right? Let's say A, B can be any elements in the set A, or B is related to A, right? Any of these two conditions should be there. So let's say if I give you an example, right? Let's say this relation is, right? I'm giving you this on the set A. So let's say 1, comma 1, 2, comma 1, and yeah, that's basically it, right? So if I just give you this set or this relation, do you think this is going to be a total order relation or not, right? The answer is going to be no, and the reason is because this over here, 2 is related to 1, but 1 is not related to 2, or 3 is not related to 1, right? Any of those are not there, right? So the basic point is every pair of elements should be comparable, and that's the condition that we need to follow. So that's it for this lecture. I know this was a pretty small one, but now I'll be giving a bunch of questions for you guys to solve. If you have any doubts, you can always leave in the comment section, and I'll make sure I upload a new lecture about it, right?